All right, so today we're on 4.4, still working with matrices. Our learning targets here is find the inverse of the matrix and then to find the identity of a matrix. So to figure out if two real numbers are inverses of each other, their product has, when you take those two and you multiply them together, they have to give you 1. So what happens here, you can tell that a and 1 over a here are inverses of each other because when you multiply those together, so I multiply my numerators there again, I get a, and then multiply my denominators, I get a, and anything over itself there, or anything divided by itself there, gives you a value of 1. So a and 1 over a are definitely inverses of each other because they yield 1. Well, if matrices, if two matrices are inverses of each other, what their product equals is the identity matrix, and that's like a value of 1 for matrices. So a 2 by 2 identity looks like this: 1, 0, 0, 1. A 3 by 3 identity, what that looks like is 1, 0, 0, 0, 1, 0, 0, 0, 1. And basically, so they're almost all zeros except this one diagonal right here is ones. This diagonal here is ones. So from the top left corner to the bottom right corner, those are ones, and everything else in the matrix is zeros. Those are your identity matrix. So if you take two matrices, so a matrix and its inverse, and you multiply those together, you'll get the identity matrix. The same thing if you reverse the order for those, unlike the other ones, you can reverse the identity and the matrix itself. The order here is commutative here. If you do that order, you also get the identity matrix. So we want to determine whether each pair of matrices are inverses of each other. We can go ahead and multiply x times y here. So 2, 2, negative 1, 4. And we're going to try to figure out if these two matrices are inverses or not. So when we multiply those together, they should give us the identity matrix of 1, 0, 0, 1. That's what we had said that's going to happen. So let's multiply this. So a good review on multiplication. So row 1, column 1. So if I multiply that, it'd be 2 times a half plus 2 times negative 1. Now I'm going to do row 1, column 2. So that's 2 times 1 half plus 2 times 1 fourth. Now I'm on row 2, column 1, which would be negative 1 times 1 half plus 4 times negative 1. And now I'm on row 1, column 2, which would be negative 1 times 1 half plus 4 times 1 fourth. So now we just have to simplify those. So let's simplify that. So 2 times a half there is 1 plus a negative 2. And then over here you got 1 plus a half. Down here you get negative 1 half minus 4. And then in here we get negative 1 half plus 1. So now we can just simply go ahead and combine our like terms in here. So we end up here with negative 1 and then 1.5 or 1.5, however you want to write that. And then negative 1 half minus 4 is negative 4.5 or negative 4.5. And then the other one there, negative 1 half plus 1 there is a half or 0.5, however you like to write that. So is that the identity matrix? Is that 1, 0, 0, 1? No. So what can we conclude? So that little 3 dots there ends up being, therefore, x and y are not inverses. Because when you multiply them together, if they were inverses, we should have gotten 1, 0, 0, 1, which is the identity. Okay, let's try another one here. Same thing, except now we got p times q. So to be inverses of each other, we want p times q to equal 1, 0, 0, 1. So let's do that. Multiplying p times q, 3, 4, 1, 2. We're going to multiply that times 1, negative 2, negative 1 half, 3 halves. So you got row 1, column 1. So 3 times 1 plus 4 times negative 1/2. And then I've got row 1, column 2, which would be 3 times negative 2 plus 4 times 3/2. So now I've got row 2, column 1, 1 times 1 plus 2 times negative 1/2. And then I've got row 2, column 2, which would be 1 times negative 2 plus 2 times 3/2. So now let's just simplify all this. We've got 3 plus a negative 2, which gives us 1. And then we've got 1 plus a negative 1, which gives us 0. And then simplifying this second section over here, I'm looking there at row 1, column 2 over there. That's a negative 6 plus 12 over 2 there is 6. So negative 6 plus 6 there is 0. Looking good. And then our last one there is row 2, column 2. We get 2 plus, that's 6/2, which is 4. So 2 plus 6/2 there. So really back over here, this is supposed to be a negative 2 here. So we've got 1 times a negative 2 gives us negative 2 plus 6/2 there. 6/2 is going to end up giving us 3. So negative 2 plus 3 there yields 1. So we end up there with the identity matrix. So therefore we can conclude there that P and Q are inverses. Because we ended up, when we were multiplying them, we ended up getting the identity matrix. So yes, they are inverses of each other. So I want you to try one here. We've got a nice little example here for you. I want you to go ahead and try that one out. So let's pause the video and have you try that one out. All right, so after you tried that one out, you're going to go ahead, you multiplied x times y here. So let's see how you did. So 4, negative 1, 2, negative 2. Going to multiply by 1/3, negative 1/6, 1/3, negative 2/3. So multiplying those, remember we're looking for it to be 1, 0, 0, 1. So row 1, column 1 here, so 4 times 1/3 there is 4/3. Negative 1 times 1/3 there is a negative 1/3. Row 1, column 2 here, 4 times a negative 1/6 there gives me a negative 4/6, which reduces down to a negative 2/3. And then negative 1 times a negative 2/3 there ends up being 2/3. And row 2, column 1 there, 2 times 1/3 there is 2/3. And then negative 2 times 1/3 there is a minus 2/3. So now I've got row 2, column 2 there. So 2 times a negative 1/6 is a negative 2/6, reduces down to negative 1/3. Plus negative 2 times a negative 2/3 there ends up giving us 4/3. So now we can add them together there. 4/3 minus 1/3 there is 3/3, which is 1. Negative 2/3 plus 2/3 is 0. 2/3 minus 2/3 is 0. Negative 1/3 plus 4/3 there is 3/3, which is 1. So yes, we ended up there with the identity matrix of 1, 0, 0, 1. So x and y are inverses of each other. All right, so we're going to next look at kind of connect this to actually finding the inverse of the matrix here. So we can figure out if two of them are inverses. There's another way if you just give it a single matrix and you want to be able to figure out if that matrix has an inverse. And if it does have an inverse, can we find it? Let's do that. So the rule here is if something has an inverse, what happens here is you actually can find the determinant. So if you remember how to find the determinant, you did AD minus BC is the determinant value. So if that value ends up being 0, if that's 0, the matrix cannot have an inverse. So let's go ahead first and figure out if it has an inverse. And if it has an inverse, then I'll show you how to do that part. I'll come back up here and explain that. So let's first check the determinant. So if I find the determinant here of R, you're going to take AD minus BC. So remember how that looks. A, B, C, D. So you're going to go AD minus BC. So what does that look like here? It looks like -4 times 6 minus -3 times 8. So we end up with -24 plus 24, which is 0. So what do we say if the determinant there ends up being 0? We said that it does not have an inverse. So basically the inverse of R, so we take R to the -1 power, that indicates its inverse. The inverse of R there does not exist. All right, so there's nothing really we need to do that, because if it doesn't exist, then we can't find the inverse. So that's what the direction says, find the inverse if it exists. Well, it doesn't exist, so we can't find the inverse. So let's come over here and let's look at P. So P here, let's go ahead and rewrite it. We're supposed to find the inverse, so we're going to do that AD minus BC thing again. So find the determinant of that. So we got to multiply 3 times 2 minus 1 times 5, which gives us 6 minus 5, which gives us a determinant there value of 1. So now that I got a determinant there value of 1, we can go ahead now and come up here and figure out, oh, so the matrix does exist. So since the inverse of that matrix does exist, the inverse of P does exist, well, let's go ahead and let's figure out what the inverse there is. So to figure out what the inverse there is of matrix P there, it says up here at the very top here in the box up here, this is where you figure out what the inverse there is. What do? We're going to rearrange it. We're going to look there and the matrix there, we're going to switch around the D and the A there. And then we're going to do the opposite of B and the opposite of C there and put it in there. And then we're going to multiply that by 1 over the determinant value. So let's come down here and let's do that. What does that mean? Well, it's 1 over AD minus BC. And then we're supposed to multiply that by, we're supposed to take D and A and swap them. And we're supposed to put the opposite of B and the opposite of C there. So let's look at our matrix here. So 1 over AD minus BC. This is AD minus BC. So that's 1. We're going to swap the D and the A there. So this becomes a 2 and this is a 3. We're going to do the opposite of B, which is -1. Opposite of C there is -5. And then 1 over 1 here on the outside just gives you a value of 1, and 1 times anything is just itself. So you just get 2, -1, -5, 3. And there's the identity, or the inverse matrix. So is equal to 2, -1, -5, 3. So the inverse matrix there of P ends up being 2, -1, -5, 3. All right, so I want you to go ahead and try out the next one here. Go ahead and see if you can find the inverse of that matrix. And we'll go, so pause the video and then go ahead and we'll go through that.